Hello everyone, today's lesson is 15.3, Experimental and Theoretical Probability. It's a short lesson. Let's get started. So at the end of this lesson, you should have the ability to, 1, find relative frequencies, 2, use experimental probabilities to make predictions, 3, use theoretical probabilities to find quantities. And the last one, compare experimental and theoretical probabilities. Let's get started. Key idea, experimental probability. Probability that is based on repeated trials of an experiment is called experimental probability. So the probability, this P, of an event, okay, is equal to the number of times the event occurs divided by the total number of trials. Total number of trials. So this is experimental probability. Let's look at example 1. The bar graph shows the results of rolling a number cube 50 times. What is the experimental probability of rolling an odd number? Okay, so what we're going to do is we're going to take our relationship that we just talked about here, and I'm just going to bring it on over. So the probability of this event. So we're looking for a probability of an odd number, okay? Probability of odd. So we're going to take a good look at this, and we're trying to find the number of times the event occurs, all right? So this would, we'd look at this 1 is odd, this 3 is odd, this 5 is odd, okay? So if we add all those together, an odd number has rolled 29 times. We have 10 here, okay? We have 10 here. This appears to be 11. And this is also 11. So we have 11. I'm sorry, I missed that one here. Hold on, back up. 11, and this is 8. Okay, so 10 plus 8 plus 11 is 29 times. Okay, and we were told right in the problem there was 50 rolls. 50 rolls. So 50 number of trials. Okay, so the odd number, the probability, the experimental probability of this is 29 over 50. Okay, so we can relate this as 29 over 50. We could also relate it as a decimal, 0.58, or 58%. Experimental probability. Example 2, making a prediction. Making a prediction. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? Okay, so again, we're going to use the probability relationship here. We will use this. Number of times the event occurs over the total number of trials. Okay, so the probability of it raining in this case, probability of it rain, is equal to 2 over 12. 2 times out of 12 days in March. If this trend continues, how many rainy days would you expect in April? So there is a total of 12 days probability of rain. So it's about 1/6. Okay. Now in April, we have 30 days. So to make a prediction, you multiply the probability of a rainy day by the number of days in April. Okay, so we're going to take 1/6 times the 30 days in April, and there's going to be 5 days. So based upon March's experimental data of 2/12, which is 1/6, and we know that in April there's 30 days in April. So that means that we're going to have 5 days in April that it's going to rain using this experimental data. So you can predict that there will be 5 rainy days in April. On your own, number 1. In example 1, what is the experimental probability of rolling an even number? Okay, so we had 50 times, and it appeared that was the number of rolls. Okay, now even, we have 4 here, we have 11 here, which would be 15, plus the 6 would make it 21. So 21 days, or 21 rolls, we had an even number. So 21 over 50, which is 0.42, or a 42% experimental probability of rolling an even number. On your own, number 2, at a clothing company, an inspector finds 5 defective pairs of jeans in a shipment of 200. If the trend continues, about how many pair of jeans would you expect to be defective in a shipment of 5,000? Okay, so we have a experiment of 5 of 200, okay? 5 of 200 is the 5 defective pairs in a shipment of 200. So that would be the probability, 5 over 200. Now you could simplify that, but we're going to have a shipment of 5,000. So we're going to take that times 5,000. 5,000. Okay, so if you had 5,000, you're going to take the probability of the defective jeans, 5 over 200, times 5,000, and that's going to be 25,000, 5 times 5, divided by 200. And that's equal to 125. So we can expect 125 pairs of jeans to be defective in that shipment of 5,000. So the second part today is theoretical probability. Theoretical probability. This is when all possible outcomes are equally likely. The theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. Let's look at what finding a theoretical probability looks like. Example 3. You randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? Okay, choosing a vowel. Okay, so if you go back to this again, if you take a look at, let me snip this out. We're gonna, for a theoretical, number of favorable outcomes over the number of possible outcomes. So that's the number of favorable outcomes over the possible outcomes. So we're looking for the theoretical probability of choosing a vowel. Now we got one here, Okay, got a vowel there, E, got a vowel here, O, and we got another one over here, E. Okay, so the probability of a vowel, okay, is equal to, there's 3 blocks over the total number of possible outcomes, which is 7. There's 7 letters, 1, 2, 3, 4, 5, 6, 7. So the theoretical probability of picking a vowel is 3 over 7, or about 43%. Now, example 4, we're going to use theoretical probability. The theoretical probability of winning a bobblehead when spinning a wheel prize is 1/6. Okay, so you have the probability. The wheel has 3 bobblehead sections. Okay, so the wheel has 3 bobblehead sections. How many sections are on the wheel? So the number of favorable outcomes in this case is 3. Okay, so we're trying to find out the total number of sections on the wheel. Okay, so we're given the probability, and that's 1/6, and it's equal to 3 over x. So we are given the bobblehead sections, the favorable ones, as 3, and the total number of sections what we're trying to figure out. So if you cross multiply this, the number of sections will be 18. X, 1 times x is 6 times 3, or 18. So there are 18 sections on the wheel. 18 sections on the prize wheel, or the bobblehead spinning wheel. Okay, let's do 3 on your owns, and we'll be done for today. Actually, we have one more example after that. We can quickly go through that too. Example 3, or I should say on your own number 3. In example 3, what is the theoretical probability of choosing an X? Okay, so we're going back to this example here. We're looking at this, the theoretical probability of picking this little X, okay, is going to, there's only one of them. So we have the theoretical probability will be 1 divided by 7. Okay, there's 7 blocks, and only one of them is an X. So 1/7, or about 14.3%, is the theoretical probability. Number 4, the theoretical probability of spinning an odd number on a spinner is 0.6. So we are given the probability as 0.6. Okay, the spinner has 10 sections. Okay, so we're looking for X, the number of odd. Okay, so we're given the total number as 10. All right, 10 sections, the total number of sections. So if you kind of imagine a spinning wheel, all right, how many sections have odd numbers? Well, this is the number X we're looking for. Odd is the odd number of sections. So cross multiply in this case, 10.6 times 10. So you're going to have X is equal to 6. So there are 6 odd number spinner sections for number 4. Okay, and the last one on your own is the prize wheel in example 4 was spun 540 times at a baseball game. About how many bobbleheads would you expect were won? Okay, so we're going to have to go back to example 4, which is the theoretical probability, which is 1/6. Okay, theoretical probability is given to us as 1/6. And we are told that we're spinning the wheel 540 times. So we're going to multiply that times 540 times. Okay, so if you take 540 times, that's going to give you 90 bobbleheads. 90 bobbleheads. So again, you're given the actual 1/6 is what the probability was from example 4. So we pulled that from example 4. And they're told that it was spun 540 times. So we take the probability times the number of times, and we get 90 bobbleheads. Okay, now we're going to go to our last example today, which is comparing experimental and theoretical probability. This is a graph showing a number cube. This is the number times it's been rolled, a 1, a 2. There's been 48 times, 53 times, and we're told it's 300 times. What is the experimental probability of rolling an odd number again? Okay, so probability of odd, in this case, we're going to take the 48 plus the 50, you get 98, plus the 49, we're going to get 147 over 300 rolls. So that's the probability of rolling an odd, or about 49%. 49%. Letter B, how does the experimental probability compare with the theoretical probability of rolling an odd number? Okay, so the theoretical probability, you found the theoretical probability is about 50%. Okay, the theoretical probability of an odd number, you think about that, you've got 6 sides, and an odd number would be 1, 3, or 5. So your theoretical probability would be 1/2, or 3/6, or 50% theoretically. Okay. So you can see there that the experimental was very close. So the theoretical probability is 50%. The experimental probability is 49%. So it's very close for letter B. So this is a theoretical, 50%. In theory, that's what it should be. In experimental, actual experiment came out to be 49. So letter C, let's compare the experimental probability in part A to the experimental probability in example 1. As the number of trials decreased from 58%. So what we're going to do on this question here, compare the experimental probability in part A to the experimental probability in example 1. So we had 49%, all right, in the above example. And it says here, as the number of trials increased from 50 to 300, the experimental probability decreased from 58 to 49. So the 58 came from example 1. We had 58% experimental probability. Okay. So if you remember way back, the first example, we had the same question, and it was 58. So as we rolled the dice more times, we increased the trials from 50 to 300, the experimental probability decreased from 58 to 49, which was much closer to the theoretical probability. Okay, lastly today is on your own. Use the bar graph in example 5 to find the experimental probability of rolling a number greater than 1. So I think there's 300 rolls here. So 300 rolls. So if we have 300 minus 48, that'd be 252 times over 300 rolls. They want to know greater than 1. So 2, 3, 4, 5, and 6. So you add all these together, 53, 50, 52, 49, and 48, you'd end up with 252. So 252 over 300 is equal to 84%. Compare that experimental probability to theoretical probability of rolling a number greater than 1. So if it's greater than 1, you're going to have 1, 2, 3, 4, 5 out of 6. 5 out of 6 chances greater than 1. So if you look at 5 out of 6, 5 divided by 6, that is roughly 0.83, okay? So that is roughly 83%. That's roughly 83.33%. So this is the theoretical, 5 out of 6. And this is the experimental, based upon the graph here. And as you can see, they're very close. So as you roll the dice more, it is the experimental probability arrives closer to the theoretical probability. Okay, so that's the lesson today, and hopefully you found it helpful. We had the two things, theoretical probability, and we had experimental probability. Think of an experiment, actually doing the experiment, the number of times the event occurs over the total number of trials, and think of theoretical, in theory, how should it go? The number of favorable outcomes over the number of possible outcomes. And that should be it for the lesson. So that was lesson on 15.3. Hope you found it beneficial. And we covered all these ICANs today, found relative frequencies, experimental probabilities to make predictions, and we found compared to that to theoretical probabilities. So that's the lesson for today. Sorry if I went over 20 minutes. Hope to see you guys soon. Take care. Have a good one.